Okay, looking at the problem, they're going to give you a binomial. And it's going to say, determine the constant. A constant is a number that doesn't have a variable in it that must be added to make the binomial a perfect square. Okay, so you're trying to come up with a number that is a constant. That means it doesn't have a variable in it. That would make x squared plus 16x plus that constant a perfect square trinomial. And there's a little procedure, okay, a little formula that you can do that will actually come up with that number. You're going to take the number in front of your x term, and in this case, what's the number in front of your x? 16. You're going to divide it by 2. Always divide it by 2. And then you're going to take whatever you get there and you're going to square it. That little process works every single time. So you take the number in front of your x, you divide it by 2, then whatever you get, you square it. So what's 16 divided by 2? 8. And what is 8 squared? 64. So that number that we're looking for, that I can add to x squared plus 16x plus 64, that number that I'm looking for is 64. So you're creating a trinomial that will now factor into a binomial squared. So that's going to factor into x plus what? 8 times x plus 8, which is really x plus 8 squared. If you want to do that little step that I just said, you can, but they're really wanting you to look at that trinomial, and it will now factor into x plus 8 times x plus 8. I could check that just to make sure by doing square, double, square. Isn't that how I square a binomial? Isn't that the shortcut? So if you square the x, you get x squared. If you multiply 8 times x and double that, do you get 16x? And you square the 8, you get 64. So we have to work on this little step, and actually we're just finding the 64 because we want, in every problem that we're working on right now, we want to have a binomial squared in it. So we can take the square root of both sides. All right, let's practice another one. Number 38, x squared minus 14x. So they're going to give you a binomial in this set of directions. And again, they're going to say, find a constant term that you can add to your binomial that's going to make it a perfect square. Yes?
Is it always going to be added?
It's always going to be added. Okay, good question. This is why it's going to be added, because you're always going to take the number in front of your x, and you're always going to divide by 2, and then you're always going to square it. So it doesn't matter whether it's negative or not, it's going to get squared, and it's going to become positive. So yes, you're always going to add that number. So negative 14 divided by 2 is negative 7, and negative 7 squared is 49. And this little process that I'm doing over to the side is called completing the square. And you might can do that in your head, or you might need to write it down. Okay? So the constant that we're going to add is plus 49. So you're always going to be adding that number. Then you have created a perfect square trinomial, and it's going to factor into a binomial squared every single time. What is that binomial? X minus 7. So before, again, I can teach you how to solve, I have to teach you this little skill on how to make a perfect square trinomial. All right? So you're probably wondering, you know it gets harder than this. Can you guess what makes this harder? Okay, when you have a number in front of your x that is not divisible by 2, which means you're going to end up with a fraction. So here's an example of a number in front of my x that I can't divide by 2. So this is what you're going to do. You're going to leave it as a fraction. No decimals here. When you're doing this process, please leave it as a fraction. So when you divide negative 9 by 2, and you square that, negative 9 is not divisible by 2. So you're just going to square your fraction, and you're going to leave it as an improper fraction. That's going to be 81 over 4. You're just going to leave it like that. You're going to fight the urge to turn that into a decimal. Okay? You're going to have to fight the urge. It's going to be easier to leave it as a fraction. You have to trust me. Okay? Now, this will factor into a binomial squared. So the square root of x squared is x. The square root of 81 over 4 is 9 over 2. If you put it into a decimal, you can't find the square root of it just by looking at it. And then the sign is going to be minus, because you're always going to bring that sign down. Okay? So right now we're not solving. We're just trying to find how to add that constant that will make that trinomial factor into a binomial squared. May not make complete sense right now till we actually get to the solving part. Okay? So we know the problem can get harder when the number in front of the x is not divisible by 2. It can even get harder when the number in front of the x is a fraction. So let's look at 46. So 46, I have a fraction in front of my x. Again, determine the constant that you're going to add to your binomial that will make it a perfect square. So we take what number? We take negative 1/4 and we divide it by what number? 2, and then we square it. Negative 1/4 divided by 2 is negative 1/8. Negative 1/4 divided by 2. Let me show you this. Negative 1/4 divided by 2 is really negative 1/4 times 1/2. If you're dividing by 2, you're multiplying by its reciprocal. Okay, you really don't need to pick up your calculator on that one. Y'all are going to get to pre-cal and you're going to be faced with tons of fractions and you're going to absolutely freak out. Alright, am I finished? Nope, I haven't done what yet? I haven't squared it yet. So negative 1/8 squared is 1/64. And then you're going to add 1/64 to your binomial. That's going to give you a perfect square trinomial, and it will factor into a binomial square. So I know it's going to be an x. I know it's going to be a minus because the middle term is a minus. And then you've got to take the square root of 1/64, which is going to be 1/8. And somebody usually says, well, isn't that what I got before I squared? Yeah. Alright, so that little process that we just did, this process right here is called completing the square. And I usually abbreviate that. Completing the square, I abbreviate that CTS. So completing the square is a little process where you take the number in front of the x, divide it by 2, and square it. Then the rest of the problem really turns into the square root property, like the second part of your homework. Alright, now your directions are going to change, and it's going to say solve by completing the square. So now the directions are going to say solve by completing the square. Let's look at number 48. So you're going to have x squared plus 6x is equal to negative 8. If you were factoring, you would want to move that negative 8 over to the left-hand side and set your equation equal to 0. But you're not solving by factoring, you're solving by completing the square. So when you're completing the square, you want this little binomial to be all by itself. Okay? You want the binomial to be by itself. You don't want there to be anything being multiplied times your x squared, and there's not here. Okay? So you want that binomial by itself. It's just like it needs to be. You're going to take 6, either in your head or over to the side. You're going to divide it by 2, and then you're going to square it. So that's going to give you 3 squared, which is going to give you 9. We just practiced that step. So on the left-hand side of the equation, I'm going to add 9 to x squared plus 6x. And in solving equations, if you add a number to the left-hand side, you must also add a number to the right-hand side. If you add a number to the left-hand side, okay, you must add the same number to the right-hand side. Now the left-hand side becomes a perfect square trinomial, which will factor into a binomial squared. What does x squared plus 6x plus 9 factor into? X plus 3 squared. The right-hand side just has 2 like terms, and you'll combine a negative 8 with a positive 9 and get a 1. Now you're ready to do what you did in the second part of your homework. You've got that little binomial squared all by itself. So you're going to use your square root property, and you're going to take the square root of both sides. The square root of x plus 3 squared is just x plus 3. On the right-hand side, you're going to put in plus and minus. You're going to take the square root of 1 and just get 1. And then you're going to ask yourself, is x solved for? Nope. How do I solve for it? I subtract 3, so that's going to look like x is equal to... Okay, you got to decide, do you leave it like that, or do you work it out and get two separate answers? You have to work it out, because negative 3 and 1 are like terms, and they can combine, so you have to keep combining if you can. So one answer is going to be negative 3 plus 1, which is going to give you negative 2, and the other answer is negative 3 minus 1, which is going to give you negative 4. Going crazy, just saw that. Alright, let's do another one. 52. We just keep looking at examples, seeing if you can kind of stop letting me do the thinking, and you can kind of think to yourself. So again, if your directions say solve by completing the square, what you're thinking of is only having a binomial by itself on one side. So that x squared plus 2x, those are your two terms that you want in your binomial, and they're not by themselves because you have that minus 5. So you're going to send the 5 to the other side. How many of y'all have ever played Red Rover before? I've used this example so many times, and I'm afraid y'all are going to stop playing Red Rover. So I like to say, Red Rover, send the constant right over. So if there's already a constant term there, what we do is we send that constant term from the left-hand side over to the right-hand side, and we get our little binomial completely by itself. Okay? Is x squared being multiplied times anything? No. If you had a 5x squared there, you would have to move the 5. If you had a 7x squared there, you have to move the 7, but you aren't one of those yet. So we need to figure out a constant that we can add to x squared minus 2x that will make it a perfect square. So we're going to take negative 2, we're going to divide it by 2, and then we're going to square it. What's negative 2 divided by 2? Negative 1. What's negative 1 squared? Positive 1. If you can do that step in your head, great. Do it in your head. So we're going to take that 1, and we're going to add it to the left, and we're going to also add it to the right. If you add 1 to the left, you have to add 1 to the right. Now the next step is that your trinomial will always factor into a binomial squared because you created that trinomial to factor into a binomial squared. X squared minus 2x plus 1 factors into x minus 1 squared. 5 and 1 combine to be 6. Next step is to take the square root of both sides, and the rest of this is what you did last night. You're not going to be able to add a square root of 6 with a 1, so you have to leave that as 1 plus and minus square root of 6. Alright, let's do one that has a fraction in it. 56. Again, your directions will be very specific on your next quiz. It will say solve by factoring. Then it'll say solve by the square root property. Then it'll say solve by completing the square. So we're going to study 4 different ways to solve a quadratic sum. There's a reason we study 4, and once we kind of get into them, I'll kind of explain which one you choose for which circumstance. Alright? So is your x squared plus 7x by itself? No. So you're going to move the negative 8 over to the other side. Once you move it over to the other side, you're going to add 8 if you want to write that step, or you can just say when negative 8 moves to the other side, you change its sign. Alright, now we've got to find a number to add to both sides. So tell me real quick how I do that. 7 divided by 2 squared. Is 7 divisible by 2? No, are you going to write this as a decimal? Never. You're just going to leave it as 7/2, and you're going to square 7/2, and you're going to get 49 over 4. okay? And you're going to add, as ugly as it is, you're going to add 49 over 4 to both sides. You're going to leave it as 49 over 4 because it's a perfect square. Just like it is, it's a perfect square, and it makes it really easy to factor. So when I factor, I take the square root of x squared, which is x. I bring down the sign of the middle term, and the square root of 49 over 4 is 7 over 2. Now, I would probably use my calculator here, although your calculator is probably going to give you a mixed number, and then you'll have to change it back to improper fractions. I'm going to show you how to do this like you did in the 5th or 6th grade. I need a common denominator. What is it? 4. So I'm going to change the 1 into a 4. That means I need to change the 8 into a 32. If you're going to use your calculator, then you're going to have to know how to end up with 81 over 4, because your calculator is probably going to give you a mixed number, and then you're going to do second fraction button again, and it'll turn that back into 81 fourths. So if you're going to use your calculator, let's practice real quick. If you're going to use your calculator on this one and you're not going to do it by hand, which I wish you would do it by hand, you're going to do 8 plus 49 fourths, and that's going to give you 20 and 1/4. So you can do a couple different things. If you do 8 plus 49 over 4, most calculators spit out a mixed number instead of an improper fraction. You can change 20 and 1/4 just by doing 4 times 20 plus 1, just by hand. Or you can hit second fraction key again and equal, and it will turn any mixed number back into an improper fraction. Okay? If you're going to use your calculator, please find out how to use it. If you don't know how to use it correctly, then you can ask me. Alright, so we want that 81 fourths as an improper fraction because it is a perfect square when it's an improper fraction. 81 is a perfect square, and so is 4. So what's my next step? Take the square root of both sides, as ugly as this is. We can do this. The square root of x plus 7/2 squared is just x plus 7/2. What do we get on the right-hand side? 9/2. What else do we get on the right-hand side? Plus and minus. Is x solved for? No. What do we have to do to solve for x? Subtract 7/2. So that means that I'm going to end up with a negative 7/2 on the right-hand side, and you're going to write that in front of your plus and minus. So you're going to end up with x is equal to negative 7/2 plus and minus 9/2. Do you leave your answer like that, or do you keep going till you get two separate answers? You got to keep going here because you don't have a square root. It's not plus or minus a square root, so those numbers will combine. Negative 7/2 plus 9/2 is going to be 2/2. Negative 7/2 plus 9/2 will be 2/2, which simplifies to be 1. And then negative 7/2 minus 9/2 is negative 16/2, which simplifies to be negative 8. Alright, that's almost as bad as it gets. Okay? Alright, for the sake of time, I was going to do 60 and I was going to do 64, but they're both pretty well the same content, so I'm not going to do 60. You don't have to do 60. We'll just omit 60. And then we're going to go to 64. Out of all the problems that we've done, every single example so far, we have never had a number in front of our x squared. So in order to complete the square, your x squared has to be completely by itself. So in this problem, before I can do anything else, I have to divide the entire equation by whatever number is being multiplied times x squared. So if it were 4x squared, you'd have to divide everything by 4. If it were a 2x squared, you would have to divide everything by 2. So in this problem, it's a 3x squared, so you've got to divide both sides of your equation by 3, and you're going to get x squared minus 5/3 x minus 10/3 equals what's 0 divided by 3? 0. Okay? For completing the square, the a value has to be a 1. You can't have anything in front of the x squared other than a 1. So before you can go any further, you have to divide everything by the 3. Alright, and then the rest of it is just like we've done. Is your binomial by itself? Is it by itself? No, what are you going to do to get it by itself? Move the negative 10/3 to the other side, and that 10/3 is going to become positive. Okay? This is as bad as it gets right here. Okay, I've got to find a number, a constant term to add to both sides. How do I do that? I take negative 5/3 and I divide it by 2, and then I square it. So negative 5/3 divided by 2 is really negative 5/3 times 1/2. So that's really negative 5/6, and negative 5/6 squared is 25/36. Negative 5/3 divided by 2 is really negative 5/3 times 1/2, which is negative 5/6 squared is 25/36. So you're going to add 25/36 to both sides. You're going to factor the left-hand side. How does the left-hand side factor? X minus 5/6 squared. You're going to combine the terms over on the right. If you're going to use your calculator, you're going to do 10 ABC3 plus 25 ABC 36. That's going to give me a mixed number. We don't want a mixed number, so we're going to hit second ABC again and then hit enter, and it's going to turn it into an improper fraction. 145/36. Okay? Then you're going to take the square root of both sides, and you're going to get x minus 5/6 equals plus or minus 145 is not a perfect square. Okay, so you have to leave 145 underneath the square root, but 36 is. What's the square root of 36? 6. When you're taking the square root of a fraction, you take the square root of the top and you take the square root of the bottom. So leave the 145 over the top. Have you solved for x? No. Yep, add the 5/6. So you end up with 5/6 plus or minus the square root of 145/6. Are we going to be able to add these two things together and get two completely different answers? Or not? Is 145, is it something I can simplify? Will 9 go into it? Will 16 go into it? Will 25? You would have to think of that. Nothing will go into 145 that's a perfect square. If it could be simplified, you would have to simplify it.
Where did you get x minus 5x?
X minus what?
Oh, never mind.
Well, yeah, I'm kind of confused when you got the x minus 5.
I took the square root of x minus 5/6 squared in this step right here.
No, like, I don't know, before you had that, it was like that.
I had a trinomial. Wait, I can go back. I had this trinomial.
Yeah, how did you go from that to 5?
Okay, you take the square root of x squared, which is the x. All we need is the middle sign here is minus, so I know this middle sign is minus. And then you take the square root of 25/36. And the square root of 25 over 36 is 5/6. Alright, the last set of your homework is to use the quadratic formula. Okay, we talked a little bit about this yesterday. Most of you seem to think that you had seen the quadratic formula before. So I need you to write quadratic formula. You are going to need to memorize the quadratic formula. It's x is equal to negative b plus or minus b squared minus 4ac all divided by 2a. The great thing about the quadratic formula is it is a formula. It's supposed to have a square root here. It's a formula. You just have to get your quadratic equation solved for, you have to get it solved for 0. And that's how you're going to know what your A.
Interruption, but can we please now have all 10th graders to go to the gym for the assembly?
Alright, I'm going to keep working a couple more examples. Sophomores, y'all will just have to catch those examples on Canvas. Alright, so the first one that we're going to look at is number 66. Everybody got the quadratic formula written down? I don't know. Y'all can do whatever you want to do. Alright, so on number 66, the directions say use the quadratic formula, and you have x squared plus 8x plus 12 is equal to 0. So the first thing that you're going to make sure of if you're using the quadratic formula is that you solve for 0. And if you solve for 0, y'all can tell me that A is 1, B is 8, and C is 12. You can't find A, B, and C unless you've solved for 0. So solve for 0, find your A, your B, and your C, and then we're going to plug that into the quadratic formula. So the quadratic formula says negative B. That means you're going to multiply your B times a negative. So that's a positive 8. If I multiply it times a negative, I get a negative 8. Then the formula says plus or minus big square root B squared minus 4 times your A times your C, all divided by 2 times your A. So you're just plugging your A, your B, and your C into that quadratic formula. So your square root is like a big parentheses. You've got to do everything underneath your square root first. So underneath your square root, you have 8 squared. You'll have to do that first. So 8 squared is going to give you 64. And then you'll have to multiply 4 times 1 times 12 before you can subtract. So what's 4 times 1 times 12? 48. So you'll have 64 minus 48. And then on the bottom you have 2 times 1, which is 2. Then you'll just continue to simplify what's underneath the square root. 64 minus 48 is 16. So you'll have negative 8 plus or minus the square root of 16, still divided by 2. And then once you get one number underneath your square root, you'll simplify that. You'll ask yourself, is 16 a perfect square? It is. The square root of 16 is 4. So you'll get negative 8 plus or minus 4 divided by 2. Then you're going to ask yourself, do I leave my answer like that, or can I add and subtract the negative 8 and the 4? You can add and subtract them. They're like terms. So you'll end up with 2 separate answers. You're going to do negative 8 plus 4 for one answer. So negative 8 plus 4 is negative 4 divided by 2. And that's going to give you negative 2. And then your other answer is going to come from negative 8 minus 4. Negative 8 minus 4 is negative 12 divided by 2. And that's going to give you a negative 6. Factoring a quadratic is usually the shortest way, but the quadratic formula, it is a formula, so it kind of takes out the thinking and it just allows you to use what the formula is asking you to do. Alright, questions about 66. Alright, 72. 72 says 3x squared is equal to 6x minus 1. So again, before we use the quadratic formula, you know, our equation's got to be ax squared plus bx plus c equals 0. And so this equation's not set equal to 0. So if you'll move the positive 6 over to the left-hand side, it'll become a negative 6x. And if you move the negative 1 over to the left-hand side, it will become a positive 1. So again, you have to make sure your equation is solved for 0 in order to get your a value, your b value, and your c. So a is going to be 3, b is going to be negative 6, c is going to be positive 1. So the quadratic formula says negative times your b. So my b is already negative. So when I do a negative times negative 6, I get a positive 6. I'm going to have positive 6 plus or minus. Put your b in parentheses because you're squaring the b. So it's negative 6 in parentheses squared minus 4 times your a, which is 3, times your c, which is 1, all over 2 times what? 2 times 3. Everybody understand how we're plugging those numbers in? So now go underneath your square root, square your b. Negative 6 squared is 36. Bring down your minus, then multiply 4 times 3 times 1, that's going to be 12. Put that all over 2 times 3, which is 6. And then you just keep simplifying. So then you're going to get x equals 6 plus or minus 36 minus 12, which is 24, divided by 6. Okay? Once you get one number under your square root, you have to ask yourself, is that number a perfect square? Is 24 a perfect square? No. Can it be simplified under the square root? Yes. What can we factor out of 24 that is a perfect square? 4. So we're going to break 24 down into 4 times 6. We're almost finished. That's going to simplify to be 6 plus or minus what? 2 square root of 6 over 6. Alright, that's as far as you can go unless 6 and 2 and 6 can be reduced. So is there a number that's 6 and 2 and 6, a number that will go into all three of those? 2. So then you have to reduce it one more step. 6 divided by 2 is 3. 2 divided by 2 is an understood 1, so you'll just have the square root of 6. And then 6 divided by 2 is 3. And you'll just have to leave it like this because you have that square root of 6 that you can't add or subtract to your 3. Y'all remember doing the quadratic formula? No? Oh my gosh. Okay, last thing. I want to talk about what this word is. Let's write it down. Discriminant. D-I-S-C-R-I-M-I-N-A-N-T. Alright? The discriminant is the value underneath the square root in the quadratic formula. The discriminant is the value underneath the square root in the quadratic formula. So that's the b squared minus 4ac part. So in the last part of your homework, it's going to say compute the discriminant, then determine the number and the type of solutions for each equation. They're just asking you to compute the discriminant only. They're not asking you to work out the whole quadratic formula, okay? Because the discriminant can tell us something about our solutions, okay? We're going to make a quick chart here. So if our discriminant is something like 25, okay? So we're talking about the when we do b squared minus 4ac and we get that one number underneath our square root, okay, and we get 25. The reason I picked 25 is because it is a perfect square, okay? So if we do our discriminant and we find out the value under the square root is a 25, that means that I'm going to have two solutions. And those solutions are going to be rational. Okay, they're going to be rational instead of irrational. Irrational means I have pi, or I have a number that's underneath the square root that's not a perfect square. So because 25 is a perfect square, when you take the square root of 25, the square root will go away. Therefore, your answers are going to be rational numbers. All right, if the number underneath your square root, which is called the discriminant, is something like a 7. So if your discriminant comes out to be a 7, again, that's the value underneath the square root. You're still going to have two solutions, but can you simplify the square root of 7? Is the square root going to go away? No. So that means your solutions are going to be irrational. Because 7 will be under the square root, and it's not a perfect square, so the square root's not going to go away. We know the square root of 7 is an irrational number. All right? If the number underneath your square root, your discriminant, if it's any type of negative number, not even going to put a number down, it doesn't matter whether it's a perfect square or not. If it's just any type of negative number, you're still going to have two solutions, but they're going to be imaginary. They're going to be imaginary. Why do you think they're going to be imaginary? Because you're putting a negative underneath the square root. Now your book goes a little bit more in detail, but if you will just use this chart, okay, and there's one more situation. If the discriminant is 0, if the discriminant is 0, that's the only time you're not going to have two solutions. You're only going to have one solution, and your solution is going to be rational because you're going to be able to take the square root of 0, because the square root of 0 is 0, so your solutions will be rational there. All right, let's just do just a few examples from this section. Again, the directions say compute the discriminant, just the discriminant. That's just the b squared minus 4ac without the square root. Then determine the number and the type of solutions for each equation. So let's look at 76. So what's the a value? 4. The b value is -2, and the c value is 3. So it's already set equal to 0. You can see a, b, and c. You're only computing b squared minus 4ac. That's the only part you're doing. So in parentheses, you're going to do a -2 squared minus 4 times a, which is 4, times c, which is 3. Figure out what that value equals. So -2 squared is 4. Bring down the minus. 4 times 4 times 3 is 48. 4 minus 48 is -44. So -44 is the discriminant. Okay, let's look back at our chart. So if we end up with a discriminant that is negative, that means we have how many solutions? We have two solutions, and what kind of solutions are they? They're imaginary. Now, you got to remember, your textbook might use the word complex. Okay? They might say complex instead of imaginary. So you need to calculate the discriminant, tell me how many solutions they are, and tell me what kind of solutions they are. All right, let's do one more. 78. 2x squared plus 11x minus 6 equals 0. So again, the directions say compute the discriminant. That's just b squared minus 4ac. So what's 11 squared? 121. Bring down your minus. What's 4 times 2 times -6? -48. Be real careful here because you have minus a negative. You have minus a negative. So you have 121 minus a -48, which is going to give you 100 and what? 169. So that's your discriminant. So 169 is your discriminant. if 169 is your discriminant, how many solutions will you have? 2. And then you've got to decide, is 169 a perfect square or is it not a perfect square? It is a perfect square. What's the square root of 169? 13. So since 169 is a perfect square, then our solutions are not going to be irrational, they are going to be rational. Now again, your textbook says 2 unequal rational. All I want is the discriminant is 169. I want you to be able to tell me there's 2 solutions, and I want you to tell me that they're rational. Alright, so let's just make up the last couple examples. What if I got a discriminant of 7? What if I got that the discriminant was 7? How many solutions would there be? 2. And what kind would they be? Rational, irrational, or imaginary?
Irrational.
They would be irrational. Alright, what if the discriminant was 0? How many solutions would I have? 1. And would they be irrational, rational, or would it be rational, irrational, or imaginary? It would be rational because 0 is considered to be a square root.